Okay,
Can you guys hear me? Can you guys hear me?
yeah, I can hear you
All
loud
right.
and clear.
So, mm, today is gonna be our first day in this session, and I'm gonna be talking about computer vision. Today just gonna be like an introduction to computer vision. This course is brought to you with by KodeCamp and Computer Vision Africa. KodeCamp is the host of the bootcamp, and Computer Vision Africa is partnering with them to bring the computer vision track. So we are going to be the one in charge of everything computer vision, and we are going to be your tutor, your mentor for the next 4 months. All right. So um, today just going to be a session, an introduction session. Starting from Friday, you are going to be doing more of coding. For today, we are going to talk about introduction to computer vision and like make you to understand about computer vision and how like it came into existence. All right. So before computer vision, it all started with artificial intelligence, right? Computer vision is just a part, a little branch or a little piece of artificial intelligence. So artificial intelligence is the simulation of human intelligence possessed by machines. So um, let me check one sec. Okay. So it's just a simulation of human intelligence possessed by machines. So it is more like our human intelligence, and then we build systems that can mimic the way we do things, that can learn from us, that can talk like us, that can see like us, that can hear like us. The goal of this is to build systems that are very, very smart to the point where we don't need to program them, we don't need to tell them things to do, but they can decide things by themselves. They can take decisions and they can take actions by themselves. So it's as simple as that. So in AI, we have a lot of branches. We have text to speech, we have speech to text. This has to do with speech, like like when you see models that talk, like robots and the rest of the things. And then we also have natural language processing, text classification, translation, data extraction. LLM is under this ChatGPT, DeepSeek, Grok, Gemini, all of them, they are all inside under natural language processing, chatbots, and the rest of them. And then we have machine learning. In machine learning, we have supervised learning, unsupervised learning, deep neural networks, deep learning, and the rest. And also we have computer vision, um, image vision, image recognition. So someone would ask, why is vision out of machine learning? We know like machine learning, vision is under machine learning, under AI, yeah. But there are things that you can do that you just do with like some simple mathematics which doesn't involve things like deep learning. Example of it is things like a simple contour detection, you know, or should I say something like H detection. You just run some algorithm. But deep neural networks comes in, which is what led us to things like convolutional neural networks, which now made things better. Like we now have max pooling and the rest of the things, YOLO, and the rest of algorithm. So that made computer vision more like CNN under deep neural networks, which is meant to be under A. All right. So we have speech, we have natural language processing, we have robotics. These are all like part of AI. We have machine learning and we have vision, computer vision. So under speech, we have things like Google Assistant, right? That talks to us, Alexa. We have natural language processing, Gemini, ChatGPT. and the rest of the guys which are coming up recently, and computer vision, facial recognition, object detection, landmark detection, vehicle detection. These are all computer vision. So when you pick up your phone and you do something like your face ID, face unlock, that is basic computer vision. Um, so yeah, that's computer vision. And machine learning. Machine learning is the application of AI that provides system the ability to explicitly do things without being explicitly programmed. Now, under machine learning, we have a lot of things. We have deep neural networks. We have CNN. We have time series, and the rest of them. But for this session, we are going to be focusing mostly on computer vision. So, computer vision is a field of science that focuses on enabling computers to identify and understand objects and people in images and videos. So, a layman term is that computer vision is the part of AI that has to do with teaching AI the ability to see. So, for example, our phones right now can't see. Like if I point my, can you guys hear me?
Yes, we can hear you, sir.
Yes.
Yes, we can hear you.
All right. So if I point my phone to for example to a bottle, my phone doesn't know that is a bottle. All right, my phone doesn't know this is a bottle. My phone can't tell me this is a bottle. That's where computer vision comes in. This has to do with teaching systems to see things and identify things as humans. So for example, this thing can detect that that's a human right there. This is a human joint, the head, behavioral detection, detecting if this person is trying to snatch things, facial recognition, like building systems that can detect and tell like something is happening. Glasses, this one is detecting glass, detecting hands without gloves, and the rest of the things. So previously, face mask detection. Previously, our computer systems, they couldn't identify things, right? They couldn't like look at things and know that yeah, we this is an object, this is not an object. They could just detect like patterns, like I can just give some patterns and then it shows the patterns and know that this is it and this is not it. So we needed to build a system, look at things and know things exactly as human beings do know things. Like I can see an object and tell me that this thing I'm seeing right here is an object. And that's where computer vision comes in. So it is simply the part of AI that gives software systems the ability to see things and objects and identify them as humans. All right, before I go ahead, would anyone like to ask any question? Okay, I feel no one has any question. Let me check if anyone's hand is up. Um, okay, you have a question. No one has a question. All right. Okay. So, how did computer vision start? Computer vision first of all started from the 1950s with pattern recognition, as I said, image processing, basic like edge detection on things and like converting things, converting colors and the rest of the things, perception, edge detections in 1970s, um, object flow and 3D vision foundation. Like these were not like deep things. Machine learning era started in the 2000s. That is in like support vector machines where we could like put things together and then the AI can detect them. But computer vision really became a big deal in 2010 with things like AlexNet, ResNet, and Vision Transformers. And also, um, AI as a whole, machine learning as a whole, has always been there. And it was always being used by heavy security, military, and the rest of the thing. But it wasn't accessible to us because one of the issues that AI had then was that there was no data. There was no data set to train systems. So it was in the days when internet started becoming a big deal, Facebook became like big. People started uploading things of themselves. Like you could upload picture of yourself. You could upload picture of like you going on a vacation. This is when AI, this is when the tech space became a big deal. Because by now we are able to gather data. And that's what lead to things like people saying Facebook sold data, they're using our data to do this to train AI and the rest of the thing. But this is when AI became a big deal. Because on before now we couldn't train system because there were no data. So and that's like after the 2010s where like deep learning CNN became like big with AlexNet, ResNet, Vision Transformers, and the rest of the things. So in 1950 to 1960, early research focused on pattern recognition and image processing. These are like trying to recognize pattern of things and they could detect something with that. Little, right? Scientists tried to get computers to distinguish between shapes, objects, and characters. Um, and then in 1970s, with the development of age detection started, like algorithms like Candy operators, Sobel operators, optical flow, text analysis, motion tracking. But these were not still big things then. It's in the 2000s that support vector machines came into pictures, things like feature descriptions, hogs, and use of statistical model for face and object recognition, and digital cameras. Then internet growth started coming up, which gave access to what image data. In the 2010 is when convolutional neural networks came in. That was like AlexNet in 2012, and models like VGG, YOLO became things, came into play. That's when we now started using computer vision for what autonomous vehicles, healthcare, robotics, and everything became big from there. So, in essence, computer vision has been there for some time, but it never became a big deal until the 2000s, especially 2010 upward, when CNN came up. So, um, what am I saying in essence is that all we're looking for, the battle, was to build a system that could do things like humans, that could look at things and then detect that this is a human being and this is not a human being. We needed to build a system that could keep that can I can give something like a rubber, a human being, and it detects that this is a human being. But there was no data set. Even if we had data set then, it would be a lot of struggles. Until the internet became a big deal, people started putting their data set up there. People started uploading things. Example of it is things like LLMs, right? LLMs was trend like ChatGPT, right? It was trend on the whole internet. Now, without us uploading things on the internet, without Facebook, without us putting our pictures out there, we won't be able to train these systems. But with the aid and the enablement of these things, we're able to train smart systems. So, what's the roadmap for computer vision? You want to be a computer vision engineer. Number one is learning Python. So I expect that most of us here we know at least a little bit of Python. If you don't know Python in this place, um, can you like drop a message if you don't know how to write basic Python in the meeting right here? Let me check. But I am so sure I expect that everyone should be able to write Python in this place. Is there anyone here that doesn't know how to write Python? And also CodeCamp. I think CodeCamp has CodeCamp as they have a YouTube channel which I'm sure has Python tutorials that we can watch, that we can use to learn. Let me search for it. Python. Okay, they have Python tutorials. So I'm gonna drop you guys beginner training session. So you can go and look at this link right here. CodeCamp has a Python session, a Python tutorial. You can follow it up. I've dropped it on the chat in the meeting, and also I'm gonna drop it on the Discord channel. Some people are having issues accessing the class. One sec. All right. Okay. So you need to be able to do Python. You need to be able to write basic Python at least up to function level. You should be able to write a function. You should be able to write a function. And also, everything you're going to see from here, we are going to handle all of them. Open CV. So I expect this is a prerequisite for every one of you guys on this call. I expect you guys can write Python at least up to a function level. I've dropped a link to CodeCamp YouTube channel. You can go and check out a Python course there. So you need to understand Python. You need to understand Python, all right? And then you need to know about input and output. This has to do with like image input, image output, being able to input images, being able to output an image. With that, you can apply things like you can do basic operations like color spaces, adding colors, blurring image, threshold, drawing. These are all important when you're trying to do things like data preparation. There are some datas that you want to use to train your models. Let's say you want to train a model to detect weapons for weapon detection. The model won't be able to, or the data set is not clear or is not showing well. Some of them you need to reduce the blurring, you need to add some more threshold, you need to like increase the contrast and the rest of the things. These are basic operations that you must do, right? To get your data set cleaned and good. So we are going to handle all of this, right? Basic operations, contour, space, threshold, blurring, drawing object, and doing the rest of the things. These are things that we're going to handle starting from on Friday. So this session is just what? Just a little intro. And then now we move into image classification. Image classification has to do with like, if I give you an image, you're able to classify that in this image is an image of a house. So the difference between image classification and object detection. So a good example is I have a picture of a pot. I give this picture to an AI model, and then I tell the AI model, what picture is this? The AI model tells me that this picture right here is a picture of a pot, and or is a picture of a black or a white pot, a picture of a dirty or a clean pot, a picture of a cat or a dog. And that is image classification. You can classify between ones and zeros, telling me that this is true that it is a cat or it is false that it is a dog. But what happens if I give it an image of 5 dogs, including including a cat, including a rabbit, including a pig, and I tell it to identify for me each animals in the picture, or each dog and each cat in the picture? That's where object detection comes in. Now, object detection is when the AI can look at this picture and then tell me that based on this picture, I see a cat in this coordinate of x equals 1, y equals 2, z equals 3, or x1 equals 1, x2 equals 2, y1 equals 1. That coordinate the XY coordinate. Let me share my entire screen so I'll explain this very well. Can you guys see my screen? I'm sharing my entire screen right now. I want to explain something.
Yes,
Can you guys see my screen?
yes, you can see your screen.
All right. Okay. Thank you so much. So this is a picture. I'm trying to differentiate between image detection and object detection. You need to understand it very well before we do anything else. You may think they are both the same thing. So I have this picture, and this picture has an image of this animal, right? This is a picture of this animal. And then I tell the AI, look at this picture and tell me in this entire picture, what is here? Is this a cat or is this a dog? The AI takes this picture in and then tells me based on this, I can tell you that this is 90% cat and 10% dog. So it looks at this image and tell me that this is a cat, or cat is one means correct, and dog is zero, meaning false. That means it's not a dog. So from this image, you can detect that this is actually a picture of a cat, and also this is not a picture of a dog. That's as simple as that. Being able to detect image and then tell me that this image is actually an image of a cat or a dog. So simple, right? We just train the image with a simple classifier and it can detect things. But now the issue comes in that I now get this same picture, but I have one. This is a dog. I have two. This is a cat. I have three. This is a rat. Then I tell the AI, based on this picture, tell me which one of these is a dog, which one of this is a cat, which one of this is a rat. Now, if we want to tell it, if we go to this using an image classification algorithm, this AI would do good and bad. Because if you look at this picture and tell me, oh, in this picture is an image of a dog, which is correct, but it's wrong because we have image of a cat and image of a rat. So we need the AI to be able to tell us this is an image, but in this image we have a dog in this coordinate. Now this coordinate is represented by, if I have a graph, right? I don't know if you guys did even if you did what is it called? This X, this Y. You did lines in school. Coordinates, vectors, yeah, vectors. So this is my X1. Sorry, I told you guys it's not gonna be it's not gonna be a lot of math here, but it's not just a simple explanation. X1, X2, this Y1, and this is Y2. So basically this is the graph, right? This is X1. So I'll put this down here a bit. So we put the image as a graph, this X1, this X2. This is this Y2, this Y1, this 0 to 5. 0 to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I want the AI to tell me that there's an image of a dog here, but in which place exactly? That's why we now apply an object detection algorithm. So this thing should return to me that this is an image of a dog in this coordinate. In this coordinate, this is the first location where I can find the image. I can find it here too, right? So this is going to be x1 is going to be equal to 0. There's an image of the dog in coordinate 0. x2, sorry, x1, y1 going to be coordinates 1, 2. Where? This is my x1. This is my y1. My y1 is 2. And then my x2 is what? X2 is equal to 0, 1, 2, 2. And y2 is equals to coordinate of 1, 2, 3, 4, or 4. So with this, we have 0, 2, 2, 4. So the AI tells us that, oh, we've seen an image, but the image is in this coordinate. So with this coordinate, we can use it and we can do anything. We can extract the image, we can crop it out, we can get the region of interest, we can blur it, we can extract it, we can do anything we want with it. So now there's a dog, but the dog is in this coordinate of x10, y12, x22, y14. We can plot anything and then we can be able to detect that this image is in this coordinate here, in this coordinate here, in this coordinate here, is in this coordinate here. This is basically what is called object detection. Please, I would like someone to ask a question before I'm back. Before 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 I continue.
Hello, can you hear me?
Yeah, very well.
Yeah, I wanted to ask, did you assume that the size of, the entire picture is 0 to 5?
Okay, thank you. Yes, as you can see, I'm just I'm just assuming this thing. Like, as you can see, I just wrote it right here, right? I'll give you an example. I manually put these numbers here. Do you understand?
Yes, I do. Thank you.
Okay. Wait, let me check if any other person has the hands up. How do I even see people that have hands up? Oluwas, kí ló ṣẹlẹ̀? Olóṣùnlá. Go ahead.
Yes, good evening, sir. Can you hear me?
Yeah,
Please,
by
can
the
you
way,
hear
my
me,
name is
sir?
Daniel. Please address me as Daniel. Thank
Can
you.
anyone
Go
hear me?
ahead. I can hear you, Olu.
Can you hear me? All right, thank you. So, please, my question is this, sir. I don't understand. I don't know if you can just go over the image classification and object detection again. Then, how you got that coordinate 0 to 2 4, please? I don't know if it's possible to go over it. I don't understand, sir. Thank you very much.
Okay. Okay. I think let me check if another person has their hands up. Their hands up. Um. mm. Terry, is it the same question? Terry asks.
No, it's not the same question. So earlier you mentioned something about maybe you asked the model, is this a picture of a cat or is this a picture of a dog? That particular question, does it make the options streamlined, picking either this is a cat or this is not a cat. So you earlier mentioned something that the I don't know if I'm using the right word, model, that the model would go through the image and check it out and clarify first off that it is not a cat, and then it picks the next option. It is a dog. If it is not a cat, it is a dog. Something like that. I don't know if I got it right though, or if you mentioned something like that. Just thought to ask.
Okay, so the model doesn't go through the image to pick things. Like it doesn't like go and be like, hey, okay, I think it doesn't do assumptions. These are things that has been trained. Like it has been trained over and over and over and over and over again. It has been trained with, let's say, 1,000 images of this cat and this is a dog. So when you give it an image, it passes it through the model that has been trained and check and compares based on what I have. Does it look like this image I have? That's why very very good pre-processing is always needed when training your model and when arranging your data. Because, for example, if I train a model with an image of a cat and the cat is looking up, or the cat is, or I train a model with an image of a cat looking very very normal, like normal standing cat, and then I now come to I give it to a user. The user tests it with an image of a cat lying down. The model will know that this is actually a cat because I didn't train it with that image. The model doesn't know anything about it. Like, I know AI is good, AI is smart, but AI is not magic. You see, AI is not magic at all. So, mind you, we are training models to see things and know that things are like humans. So, imagine since the way a kid, I'm just going to use this analogy, right? Since we're a kid, every day we see different things. And this is how computer vision works. This is how computer systems are trained. Every day you see a picture of a cat. Now that is being registered in your brain. So if you observe, if I give you something that you've not seen before, let me mention something that I'm sure none of you guys have seen before. Um, you have never seen a picture of a rock that is in mass. But after I show you that picture of rock in mass, if I show you next time, you'll be able to know that picture. But after like 2, 3, 4 years, you forget it. And this is because, using the example of being a kid, you were raised up and then you saw spoon. You gave a name to it. This is called spoon. You kept it somewhere as a label and as a data set. Okay, let me know his book terms. You kept it somewhere as a name and an object. The next time you see spoon again, you see spoon again over and over. You see spoon in different colors, in brown, blue, black. You can identify that this is a spoon, all right? And this is not a spoon. And then I show you a Ferrari. You've never known a Ferrari before. And then I tell you this is a Ferrari. The first time you didn't know. The next time you will know. The next 3, 4, 5 times you can identify different types of Ferrari. That's exactly what computer vision is. We pick objects, we pick things, millions of those things, because let's assume you've lived for 10 years, for 15 years in your life, for 20 years. You have seen this thing over and over again. And the more you store them in your brain, it keeps on rewinding, you keep on seeing images of that thing in your brain, it keeps on training yourself to know these things. And that's what we are trying to achieve with AI. So we give this thing millions of images of a cat standing this way only. Or just, let's say I give it like 5 images of a cat standing this way. And then I gave it to a user, and the user gave this type of image of a cat looking like a balloon. The AI won't be able to detect that this is a cat. Even if it does, it will be very, very low because we didn't give it this image. So what we do now is that we give it a lot of images of cat looking in cat in different coordinate, in different style, a cat jumping, a cat standing, a cat lying down, a cat crawling, a cat sitting. So when the AI looks at this, it memorizes it. Let me just use that word, right? It memorizes it. it learns about it. It learns about the pattern. It learns about this thing and then stores it in its brain. So when the user comes to it and give it an image like this, it picks this image and compares to what it has somewhere that it was shown, that it trend on. And it compares and it's like, okay, this image I think is 90% close to what I have. Like this is not magic. There's no magic. It's just simple mathematics. For example, um, is matrix. Matrix is what we use to convert this image from what we see to pixels. I know we convert it to pixel, yeah, we do some things, but after converting it to pixels, we use metrics to pass this image from this particular layer in our AI to the next layer to make to convert it to non-PRS and the rest of the thing. This is where metrics comes in. So metrics comes in when I'm like, okay, this is the image. I want to do this computation. I want to do this thing. That's why we use metrics. Vectors comes in when I want to pass this image from this part of the when I'm training the model. We are going to talk about this later on. When I'm training the model, I want to pass this model, connect it from here to here. That's where vectors comes in. I know you don't understand whatever thing I'm writing, but let's say from the beginning of the model to the output, that's where vector comes in. Simple as ABC. Metrics is what we have, like we say this image is of dimension 0 or 4, and then um of size, let's say size 8. That's where it comes in. Or we do things like pixels, 2000 pixels, kinikon up and down. You see, then calculus comes in when I'm like, okay, this model has gotten to the end of this it has gotten to the end of this network that I was training. I want to pass it back, and I want it that as I'm passing it back, bro, how sure it is that this is actually a cat reduces. That's where calculus comes in. And as that keeps on going on, the thing keeps on learning, and we store those data that it was training somewhere. And the next thing we use it to create a model. Now we'll pass a image into that model that we train. It compares this, it first of all convert this image from a normal image that we see to pixels, to non-PRS, and that is where that's metrics, right? After converting it compares it to what it was trained on. And if it is close to it, it tells us this is 90% cat, or this is 0%, 0% dog. Like these things are very, very easy. It's no magic. There's no magic in this thing. So that's what happens. So we train this AI model with images of cats, and then we give it an image of a cat and tell it, and it's like, oh, based on this image, this is what I think it is.
Okay, please, I have one more question. So, is it safe to say that I understand that there are more medical related purposes, for example, ECG classification or X-rays. So, is it safe to say that those models have been trained with a ton of ECG results, X-ray results, and also, if
Which
yes,
model?
how? I understand that there are medical models out there that are used in medicine, or rather for doctors, where maybe they have an ECG results and they could upload it and it could maybe classify it for them, tell them something about that particular result that they got.
Mm-hmm.
So my question is, yes, I understand all of those are done with computer vision. So the outputs it gives, the I would not call it a diagnosis, but yes, the diagnosis it gives, is that also being handled by computer vision?
Okay. So you're asking me that we have a picture of like brain tumor, right? Okay, use brain tumor for example.
Exactly.
Hmm?
Okay, I should use it in explaining, right?
Mm.
Okay, so let's say you have a picture, or rather an X-ray from someone with a brain tumor, and then you upload it to a model that had been trained with um lots of data from other people's X-ray results, and it was able to match that. Okay, yes, this is actually a brain tumor, right? So how?
Mm-hmm.
So usually it would give like I said, I would not call it a diagnostics, but it would tell you, okay, yes, this is a benign brain tumor, or this is maybe a serious brain tumor and stuff like that. So I'm asking, that's diagnosis to give. Is it also based on computer vision, or is there some other thing out play there?
It's computer vision. We just look at the image and then we tell that this image is an image of benign. Simple. But before we decide and we before we before we decide that the image is an image of a cat or image of benign, we look at the accuracy. How accurate is it that this image is image of a benign or not? So if it is like above 90% or 80%, then we are sure. And the AI is sure. The AI is sure that it is actually an image of benign. It's as simple as that. Do you understand? So that one, there's no LLM coming in there. I don't know, you were expecting me to say there's LLM. There's no LLM. We trained it with image of a benign and image of not benign. And then looked at the image and tell me that this is actually benign and this is not benign. It's simple as that. I've answered your question.
Yeah, yeah, you have.
Okay. Um, Image classification versus object detection. Is that lady still here? Or if she's left, I'll just
I'm
move
still
on.
here. I'm
Okay, what
still
don't you
here.
understand about? Do you understand now after I've answered that guy's question? Or should I say it again?
No, I
Hmm?
understand the guy's question. I understand this question. But the
Now, I
issue
mean
I
your
have is
question.
that no, I don't understand that, especially that dimension. How you got that 0, 2, 2, 4? I don't understand this.
I'm just the one that put it. It didn't appear. It didn't fly from heaven. I just put it. There. Okay. So, do you understand the difference between image detection and object detection? Sorry, image classification, object detection. Should I recap that? Or your problem is it how the numbers appeared in the place?
Please recap please recap the meaning of image classification and object
Okay,
detection, please.
let's read from Google.
Okay.
Um. Mhm. So look at this. So we have this picture of the cat. All right.
Yes, I'm with you.
Yeah, sure. Young man, what are you doing? Where's my screen? I didn't expect this class will last this long. So we have this image of the cat, and then we've classified that this is actually a cat. This is not a dog. Like we're trying our AI for our AI to know that this is actually a cat and not a dog. So image classification just has to do with us giving an entire image to a model, then the model telling us what this image is. That this is actually an image of a cat and this is actually an image of a dog. Understand? That's what is here.
All right, sir. Thank you.
No, I'm not done. I'm not done. Wait. Okay. So image classification identifies a single label for an entire image. All right. So as I said, we know that this entire image is a cat and not a dog. But now we now localize it. Localization means we say in this entire image, this is the particular part where the cat is. All right. We know that this particular part in this image is where the cat is. And that's automatically what is object detection. Like it's not magic. There's no big deal here. So let me just read this. Object detection identifies the object, locate multiple objects within image using bounding boxes, whatever thing. Kiniko. So I have this image, right? And then I give it an image, and I tell you what is inside this image. This is an orange. I tell the AI what is inside this image. The AI tells me this is an image of an orange. I am sure that this is an orange by 90%. Now, this automatically makes us know that this AI is 100% sure that this is an orange, right? And 10% not sure this is an orange. And automatically, this makes this is 90% accurate to be an orange. And we say that this is an image of an orange. But an issue comes in when there's orange and there is a I did draw mango. No vex, so I beg. And these are mango, and then and this is a banana. This is a banana. I pass the same image to the AI. The AI can tell me that this is an image of an orange, which is correct, but it's wrong because this is not only an orange that is here. We want it to tell us that this is an orange and the orange is in this particular location in this image. And that's where localization comes in. What they tell us that the orange is in this coordinates in this image, and that coordinate is called bounding boxes, or I can just call it landmark. These are called bounding boxes in an image. So I'm using, for example, let's say this is the entire image, and I want to find it in a vector space. Sorry for using that word. I want to find the image in the image. I want to find the image of an. I want to find an orange in the image. So I want to locate where is this orange in this image. If you did vectors in school, how do I explain this and make it not to sound like math? Okay, okay. So I want to identify that this is this guy in this place. This is my X, for example. This is my Y. This is Y2. This thing I just think that I just came up with right now. It wasn't in this it wasn't anywhere. I just came up with it. And I want to locate where is this orange in this particular image. That's what it's called localization. Then I come and I'm like, this orange is in this point. It's in point 1, point 2. All right, and is in point this point is in this point. This is the point where this orange is. So with this, I can locate where this orange is and I can plot it out, or I can use it for anything I want. So how am I able to locate where this orange is? So let's say this is 1, this is 2, in a graph, in a line graph. 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6,
Hi,
7.
Daniel.
Yeah?
I apologize, but we are seeing your Google screen and we cannot exactly see the pens stuff you're doing.
Are you serious? Can you see this?
It has been your Google screen all through your browser screen.
Okay. Um, okay, let me try again. Can you see now?
Still loading. It's still
Can you
loading.
see now? Wow. Hey, wait. Can you see now?
It's still loading on my end. I don't know if anyone else can see. It's still loading.
It's still loading.
Just small rain wey fall. Everywhere don't collapse. Okay, I think you should see now. I can see. Can you see now?
It's still loading.
Not yet.
Why no vex so? Are you guys see now?
No, we're not.
No,
Still
no, no,
loading.
no, 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 no.
Interesting. Hey, can you see now?
Not yet.
No,
Yes.
not yet.
Ah, be like say, wait, let me check. Hmm. Okay, let me share again. Can you see it?
No.
Ah, let me leave the call and join back.
So I think if you leave, since you're the host, I think we all leave too. So maybe we could join after you start the meeting again.
But I don't think the issue is my internet though, because it's fast. Internet.
I'm not seeing your screen either, sir. So I think it's general.
Hmm. Okay, it's working now, right? You guys should be able to see my internet.
Yes.
Like my internet.
Yes.
Yes,
Yes. It's
yes,
working now.
yes, yes,
It's working now.
Did you guys see
Okay.
this?
yes,
Did you guys see this thing when I drew it?
yes, yes.
We did
I
not see it
can
when you
see
drew it, but we can see it now.
Okay.
So I need to start from beginning. Oh my goodness. Oh my goodness. Okay. So shit. Oh my god. Okay. Oh my goodness. Oh my goodness. So I have this image. All right. I have this image. Then I have this. Ah, be that one now. Marafa. Can you mute? Okay. So we have this image of orange. All right. We have this image of orange, and then we give it to this AI, and then tell the AI like, "Hey AI, tell us
We are
if
not
this is
seeing the
an
screen
orange."
again,
Ah,
like the image.
what can you see? What are you seeing?
Now we can see it now.
Hmm. Okay, so we are like, this is an image of an orange. Can you tell us what this is? The others are this 90% image of orange and 10% image of not orange. So we know that this is actually an image of an orange. But now there come a situation where in the image we don't just have orange, we have banana, and then we have this quiver. The AI is meant to tell us that there is a quiver, but on a particular place in the image. That's where localization comes in. So the AI is telling me that there's a quiver, but the quiver is in this particular bounding box. This is what is called bounding box. This thing here is in this location in this particular image. So for me to locate this image, this place, I need to be able to find that this image is actually on this location, is in these coordinates, in these coordinates, all right, is in these coordinates. So, and this. Let's say this is my X and this is my Y. This X1, this X2, this Y1, this Y2, and this is level from 0 to 5. We can say that this image, the X1 is in the 0 to 5. The X1 is in where? Is in this place. 1, 2. This is 2, right? 2. Y1 is in where? 1. Let's say this is 1, 2, 3. It's in 3. X2, which is here, is probably 0, 1, 2, 3, 4. Is in 4. Then Y2 is in 5. So it's as simple as that. So with this, we can know that this image is in coordinate 2, 3, 4, 5. And we can use it and we can plot. So if I plot here, if I draw something here, and then I draw another rectangle here, and then I pick this angle to be here, I draw here, and then I draw another angle here, I'll be able to get this image. And that's what is called localization, and that is object detection. So I know that I can detect that there is an orange, but the orange is in this very place in an image, in the image. So that is what is called object detection. I've answered your question.
Yes, thank you so much. Thank you.
Okay. So now, object detection, segmentation, semantic segmentation, and there's pose detection. Pose detection has to do with like detecting someone's pose, is standing, sitting, and that. So what are the tools? There's scikit-learn, there's YOLO, there's YOLO NAS, there's PyTorch, there's TensorFlow. We are gonna handle this. We are gonna handle this, I guess. We're gonna handle this one and this one. If you know these two, you are good. You can pick up every other thing and you'll be able to handle it. So, oh god, that took a lot of my strength. So, application
Please,
of computer vision, facial recognition,
please, I have a
biometrics.
little question.
Okay, right.
Hello.
Mm-hmm.
Okay. My question is, are we going to pick up all the ones we are seeing full courses? Is it part of what we are going to do
Are
within
we going to
the
do what?
training?
Are we going to do what?
All the courses we are seeing, written full courses, all those ones that the objects identification and all of those,
Yeah,
are we going
we are
to
going to
do it
we are going to do
part of the
everything. Yeah. Yes, we are going to do all of this. We're going so with handling this, you can choose to use any
okay?
of these
And
tools.
I will also solicit that while doing it, we can also try real world projects as well, because it will also be helpful.
Yeah, we are doing that too. We are going to handle reward projects. All right. Okay. Um. Um. Okay. Let me check. Does any other person ask question before I move into applications? No one. Okay. There's no one's hands up. So we are going to handle all this. Everything you're seeing here, we are going to do all of them. The tools we are going to do this. We are going to do this. We are going to do this. We may not touch circuit learn. This is yellow NAS is the same as yellow, right? Also, we are going to do some other things too. All right. Okay, application, facial recognition, biometric security like fingerprint, employee monitoring. Okay, let me show you guys this one first. Facial recognition, then we all know facial recognition. This biometric system detection where you can use you use computer vision to look at someone's fingerprint and you can classify this fingerprint of Amos or fingerprint of Ibrahim. Okay. There's employee monitoring where you have a camera somewhere and the camera monitors employees in the office who is standing up, who is not coming to the office, who is lying there, was at work, who is sitting down. There's a lot of things you can do with computer vision. Let me share my entire screen so I can show you guys. Man, I didn't expect this to last this long. Okay, so like this one, we can monitor this employee is sleeping, this employee is working. See, this one is sleeping, this one is working, this one is normal and active. We can monitor like people in the workspace and who is in the office and who is not in the office. Things like this. One sec. So we can monitor people standing, how long they've stopped, how long they've stood, and a lot of things. People use the company Amazon Go. Amazon, was it called Amazon Go? Yes. This is a very, very good example where you just come into the shop and you don't pay for, you don't use your card, you just walk in and you pick things. This from A to Z uses computer vision. You just walk in, go into the shop, you don't even need to put your credit card or anything. It knows you and debits from you automatically. You see. So it knows that you pick this, you pick that. If you dropped it, it knows that you've dropped it, and and, and subtract it from your cart. All right. There's livestock detection where you use AI to detect animals and tell if they are sick, if they are not sick. That's like what we've been working on with my project. And there's access control systems, there's crop detection, there's medical imaging analysis like the brain tumor detection, there's shelf monitoring and retail. That's exactly what you saw here. It tells like this woman carry this cheesecake, carries chicken, carries this, and when she leaves the shop, the thing deducts automatically. Um, there is fire smoke detection, remote monitoring, license plate recognition, autonomous surveillance, surveillance vehicles like Tesla. Tesla uses computer vision from A to Z, computer vision, and then some um, LiDAR, autonomous surveillance robot, traffic monitoring, infrastructure inspection, automatic gradient education, and a lot of other things. So there's a lot of applications for computer vision, and we are going to play around with a lot of them, even from like from your second week and your third week, you start playing around with a lot of them. So before you even get to the project phase, you must have done like two, three, four projects. All right. So installing IDE. I don't I don't know if we can do this today. It is basically I wanted to install Python. Okay. So all you need to do is just to go to Google Chrome and you search for PyCharm and you download PyCharm and install. I already have PyCharm installed. Or we'll just undo this on Friday when we come. We'll do it and then we start writing our code. Because for today, I'd like us to stop here. So does anyone have any question before like I call it a day?
So I do have a question. Last one actually. So when you mentioned object detection, so I haven't seen what's it called? Annotation, data annotation area. So I wanted to know if that is what it is actually know what particular it is in, right?
Huh? Hello?
So I was saying that I have been seeing data annotation everywhere, and I'm not exactly sure what it means. But after you explained object detection, I was wondering if it says what is actually used to know the placement of those objects, like what part of the image has this particular object and stuff like that.
Very correct. That's true. What you say is true. That's what data annotation is used for. Data annotation is used for telling the AI, okay, this is where the image is, right? Now, I want you to know that in this image that we have right here, this way a cat is, this way a dog is. So I can use like 5 images to train an AI model. So let's say I have 5 images that has 100 images of people, and then 5 images of spoon. I can just give it to the AI and then annotate all the 100 people and then label them and tell it in this image we have 100 people in this location. Use it to train your mod to train yourself. And the AI will use it and know like, okay, this is where people is, this is where people is. And then it can detect people. That's where annotation comes in. It's mostly used for object detection. And what you're saying is correct. Yeah. Does anyone have any other question?
Good evening.
Okay, so good
Please, I'd
evening.
like you guys
What
to
I want
raise
to
your hand. Sorry. I want to see your hands rest up, then I call you. You don't just unmute and talk. There's no one's hand up. Janet, you can go ahead, but anyone that wants to talk next should raise his hands.
Okay, good evening. It's not actually a question. I just want to ask about the Python you mentioned earlier on the YouTube channel. So showing like Python fast API. So I want to confirm if it's still the same thing.
Let me check. Does another person have another question? I'm gonna send you another one. Okay, does CodeCamp have a Python tutorial? Like a Python, does CodeCamp have a Python? Okay, is not here. Okay, wait, let me search. While I'm waiting for that, Alvin, you can ask your question.
I have a question on the installations that you've said, for example, for PyTorch. Like, can we have a list of the installations that are required before Friday, even if it's communication through the Discord, so that, you know, by the time we already have, we don't take too much time. So yeah.
We'll do it on Friday. Don't worry. Like that's one of the things we are doing on Friday.
Okay, thanks.
Installing IDEs and uh, okay. I'm taking the Python class right now. Cook already has it. I sent it on the Discord. Um Alamu Abdullah.
Yeah, good evening. Please, I just want to ask, maybe we can have access to your slide so we can use it as a note, please.
I think it's on the, are you on the LMS?
Yes, I'm on the LMS, yes.
I think the slide will be there.
Okay, okay, okay. Thank you.
But and so whose one is this? This class, guys. I really appreciate you guys. I think the next session is gonna be on Friday. All right, bye.
Thank you. Bye bye.
Please, next time I want you guys to address me as Danny. I don't like that sir something, sir something. It's not my thing. God bless you.